Today, on my live feed, I'm going to talk to you about something that I saw on LinkedIn and something I've talked about several times in the past. And this is a DARPA project, actually, called Insect Allies. And essentially, the system that they're talking about is still in like the pre-production phase. But this is DARPA we're talking about here. So, for those who don't know, or those who are outside of the United States, DARPA stands for the Defense Advanced Research Projects Agency, DARPA. And they do a lot of different projects. Obviously, those who are aware of it know that that's quite the understatement. It's a government organization of the United States. But there is a really interesting system or idea that is being researched by DARPA right now, and that's called the Insect Allies system. The Insect Allies system is essentially the idea that you could take well, let me back up. Let me explain it to you this way. For those who don't know, different organisms can vector pathogens, so especially plant pathogens like aphids, whitefly, mealybugs. A lot of organisms that have kind of like a mosquito has like a proboscis style mouth part, a sucking mouth part. A lot of insects that have sucking mouth parts, whether they feed on blood or whether they feed on plant blood, phloem, will transmit viruses. Or they can be vectors for other pathogens like bacteria, sometimes fungi, protozoa, all kinds of microbes. And they can vector these microbes. Now, not all microbes that are vectored by an organism are going to necessarily be bad. But a lot of them tend to be pathogenic. Sometimes they're even pathogenic or they're very much bad for the host organism too. A lot of people don't know this, but for example, the malaria organism that infects mosquito, the organism that causes malaria in humans, it's not very good for the mosquito either. The mosquitoes aren't doing so great when they're also kind of infected with the malaria. Now that's not true for all organisms, but it is true for that particular example. There's also Pierce's disease, which I just made a video about. Well, I made a video about Graphocephala fenahi, which is the rhododendron leafhopper, and it's a vector. Well, it's a carrier, but it's not necessarily a vector of Pierce's disease, which is Xylella fastidiosa. So it can carry it, but we don't know if it necessarily vectors it. And I guess in the case of a lot of leafhoppers, it can feed, the pathogen can actually feed on like the cuticle of the organism inside of it. So it's not great for the leafhopper to have to contract this organism and then vector it to its host as well. So not all pathogens that are vectored by insects are like on their side or anything like that. But back to the DARPA program. So this Insect Allies system is essentially one that would take insects that vector pathogens, or really it doesn't have to be that, I suppose, conceptually. But they're looking at that sort of model to be vectors for not pathogens, but for microbes that would essentially be able to have the opposite effect on plants. So instead of having a virus that would infect a plant, it would infect the plant, but it would cause a beneficial effect, not a negative effect, not a deleterious or phytologically or physiologically harmful problem. So that's kind of the idea, is that in a government emergency, the government could take these organisms, the virus or the fungus or whatever has been engineered essentially to have a good positive effect on the plants. Maybe it makes it very drought tolerant. Maybe it makes it very tolerant to a wide range of environmental hazards. Maybe it makes it produce better. who knows? That it's, they're still trying to figure out whether it's even viable at this point. There's a lot of possibilities, and DARPA is one of those programs that is in production phase for a long time, and then eventually, they either have it or they don't, or they employ it or they don't. But sometimes they just find out that it's just not cost effective or it's not worth it, even in an emergency to use. But you would take these microbes and you would place them into a suitable host, or suitable vector, rather, and then you would deploy those vectors out. So it's kind of like the Caltrans myth that, and if you're not aware, that Caltrans is like deploying broad mites and russet mites over over California to like surreptitiously undermine the cannabis cultivation space, which I've made a video about as well. And spoiler alert, that's not happening. That's very ridiculous, especially the broad mite thing. But the rest of my thing doesn't make sense too. And if you're interested in knowing why, you can check out the video on my YouTube channel, Zenthanol. So, and I'll be also putting this live on my YouTube channel as well. So if you only saw parts of this, or you want to see the full thing, you can go to my YouTube channel and you'll have the whole video accessible to you. Anyways, so it's kind of like that. The idea would be to use an organism like an aphid, for example, and you would put the microbe inside the organism, and then you would send it out, and you would deploy it maybe aerially, who knows, and that organism would feed on the plant, I guess, and then infect the, or inoculate, if we're not trying to use sort of words with negative connotations here, because you're not trying to hurt the plant, right? But it's still infection, technically. But you would inoculate the plant with this microbe, this beneficial microbe, but in an emergency, I guess. So it's kind of odd, in my opinion. It's not necessarily a terrible idea, like conceptually, theoretically. I can see where this kind of a thing would be a sort of a hybrid, sort of a biological hybrid idea. But I kind of feel like using such a thing in an emergency, I'm not sure, like, I guess it would depend on the microbe and how it would affect the plants. That's the really important part of this whole situation, this whole idea, this whole concept. Because you would have to consider, even if you had a microbe that can be beneficially inoculated into the plant through a host, even if you had that, a few things come out and sort of stick out in my mind. One is that you would have to have the logistics necessary to span the area under which the emergency is happening. And this could be a huge space. I really don't understand what the emergency could be. What would make sense here? Because to me, the sorts of emergencies that require like rapid development, I guess it could be an epidemic. So I suppose that instead of like an environmental buttress, you could have something like, well, for example, right now, for those who don't know, there's the citrus greening disease that's caused by phytoplasma that is vectored by the Asian and African citrusilids. And that's incurable, basically. And it has been a huge problem for citrus everywhere. But primarily in the U.S., in Florida and California, we know of Huanglongbing, the citrus greening disease, or yellow dragon disease in Chinese. And it is a big problem because it's very hard to deal with, and if you detect it in one plant, you can pretty much guarantee that all the other plants in the orchard has it. So it's a really big problem, and the only way to really stop it right now is quarantine. And, for those who aren't aware, like, that's not impervious. There's no perfect quarantine. Eventually, somehow, that quarantine will fail, and it works all the way up until it doesn't. And then there's no recourse for the orchard grower. You just have to pull out all the trees and plant new ones. And that's a really, that will kill a business. That will kill an industry if it gets out of hand. And it's something we're dealing with currently in California, which is where I live. So in that kind of an epidemic sort of situation, I could totally see how potentially you could maybe sort of send your own organisms out with a microbe that will defend against it. And I guess that kind of makes sense, but then the other sort of side of that coin, or several sides to that coin, is like it would have to be an organism that doesn't cause additional damage to the host, or at least not a whole bunch of damage, I suppose. So you'd have to find a vector that was not super pestiferous. You'd have to find like a vector, kind of like Graphocephala, the leafhopper I was talking about. It does infest a lot of plants, but it doesn't really do a lot of damage. Not a lot of like cosmetic damage. It does suck the phloem from plants, yes, but it's not really. It doesn't really cause a lot of physiological deformity or anything like that. It may stunt growth a little bit, and even in severe populations, it's really not a big deal for most cultivators. That's why when I made the video, it was very hard to find information on it because it's just not considered threatening. And to be honest, it's sort of like, well, I suppose you could say it's sort of refreshing to go over a pest that's not really a big pest, because they do exist. It's just that so many other pests are so much bigger of a threat that you have to deal with them in that way. But in that situation, you might want to do that, and you might want to make sure your host, your vector isn't a big problem itself, that it doesn't vector other pathogens, I suppose, and that sort of a thing. So I could see how that could work, but logistically I would feel like it'd be very challenging to deploy. And also I feel like it would be better to use preventatively. Well, most treatments are probably better, for the most part, are better preventatively. But they're not going to necessarily be better in response, or they're not going to be quite as good in a curative fashion when you're responding to the problem, because at the point of detection, you might not know how deep the rabbit hole goes. You might not be aware of how bad it really is when you detect it at the first point. But you might find out very soon after that, oh, it's actually not a big problem yet, and then you can deploy. But if you find out that it's actually not the case, and that it's actually a huge problem, and you've just detected it now, you might not be able to save your crop, or your orchard, or whatever your problem is, in time. So I could see that working out, and an article that I was reading by Science Alert talking about how, in the title, the Pentagon wants to create a bioengineered insect army to protect crops, in quotes. I could see how certain parts of the DARPA, certain people in the DARPA organization are saying that it could work preventatively as well, and the technology has possibility for alternative applications, and a lot of heady, high level, high tech things like that tend to have multiple ways of application. They tend to have multiple possibilities just because they're so complex, and DARPA is dealing with them in that way. DARPA likes to deal with complex things like that. So I guess that kind of makes sense. But then, of course, the other sort of problem is that people are worried that it can be weaponized, right? Because whether you're a supporter or not a supporter of the technology, just like any technology, somebody can use it for good, which is subjective, and somebody can use it for bad, which is subjective, and where you are on that line can differ, right? So you have that kind of problem as well, right? Could these pathogens that are bioengineered, can they leak into the ecosystem, essentially? Can they become unchecked? Can they horizontally transfer the genes that they have to others that are related? Could the germline be infected of the plant in such a way that it, maybe passes some of those genes along as well into the plant? Who knows? I think that's an understandable critique, certainly. And it's the sort of thing that you should consider when doing or when creating a technology like this. And DARPA's not stupid. I'm sure that those sorts of things, I'm sure, have occurred to people way smarter than I am and way more qualified to talk on the subject. But people who are going to be talking about this and people who are going to be reticent to any sort of bioengineering at all is obviously not going to like that, certainly. But at the same time, I guess I could imagine a situation where if it really is the best way to apply a microbe to an area really easily, then that's what it is, right? But I have a hard time believing that this would be the most efficient way of doing that. So perhaps there are other applications that haven't been thought of yet, and so as the technology develops, maybe other technologies that are not being developed by DARPA will come online and maybe facilitate this technology, or maybe it will breathe new life into it, or maybe a totally new purpose could be developed. Who knows, really? Or maybe all of this sort of research ultimately doesn't go anywhere, and the program is defunct, and the original intent to use an insect pest to vector a good microbe into the crop doesn't work. But all of the research that went up into the program could be used for other projects, or maybe we have a better understanding of how the host pathogen interaction happens. We might benefit from that. We might benefit from an understanding or a greater understanding of how pathogens become vectored in general. And that can be very beneficial as well. So even if the program doesn't end up panning out for its original intent, it may actually be very beneficial in other capacities. And that's something that I'm really interested in seeing as this develops. DARPA has also done some other interesting things with insects. For example, I remember talking about a cyborg beetle, and some people may have seen the viral videos that were going around of cybernetically, I guess you could say, altered moths and beetles, wherein which people were able to direct their flight by I think by electrode was how it was done. Essentially, they were able to wire the brain with an electrical impulse, and people were able to kind of make a beetle, like a large beetle, like bank right or bank left, depending on what neurons were fired and things like that. So that's kind of, a lot of people are uncomfortable with that idea because it might remind people of things like the various sci-fi dystopian hybrid or like cyborgs in the future to come, that sort of a thing. That what does it mean to be human, and sort of that there is no ghost in the shell, sort of monism or dualism, kind of philosophical problem like mind body, and where does the human soul, or whatever you consider that to be, where does that end, and then what does it mean to be human, and where does that end and where does that begin? Not to get super philosophical, but those are the sorts of, like I said, heady, high-tech ideas that DARPA deals with, and other organizations like DARPA deals with. And I'm not the first person to talk about this, surely, especially since the program's being run. So other people are thinking about this, other people are considering these options. Should we be worried? I don't know. Probably you should always be worried every second of your life about whether or not something bad's going to happen. I don't know. I don't spend my time worrying about that too much, but I do think that it's an interesting conversational topic, and since it's in my wheelhouse of phytopathology and worrying with, dealing with pests and pathogens and disease vectors and that sort of a thing, is something I wanted to bring to bear and talk about. So I guess that's really all I have to say on the matter for the most part. It's an interesting concept. I'm not necessarily for it or against it. and it's so early in its infancy that there's really not very much to say about it until something way more concrete comes online. But I kind of see some issues with it, and not from like a philosophical or like moral standpoint, just like a technical standpoint. You know, if you're just coming online watching this, basically those are that like the logistics kind of doesn't make sense to me. Oh, I'm out of focus. There we go. The logistics doesn't really make sense to me. I kind of don't know what possible emergencies could be. Where like a chemical agent, for example, wouldn't be a better option, or like, um, could you do you need the pest host to make the microbes to like inoculate the plants? Like, why can't you just apply them through like a drench system or a spray system? Wouldn't that be a better system? Why do you have to introduce a pest to vector the microbe that may also do some maybe incidental damage to the crop? But you're kind of relying on this biological organism to do what you want it to do. And frankly, um, throughout human history, that's not always worked for us. But I guess microbes are also biological, right? So that's also a true statement as well. And the more that we use like bioinsecticides, mycoinsecticides, mycoherbicides, mycofungicides, even, the more that we use biological organisms in this way, we have to understand and we have to be okay with the fact that in a constantly evolving system ecologically, we have to understand what the subsequent consequences are, and they're not always going to be known. In fact, I would argue that it's never possible to know 100% of what's going to be in the future, or what are the consequences of an action. You could know, or you could perhaps surmise what a lot of them could be, but you're probably not going to get all of them, because the consequences could be very abstract and maybe not even happen until like 200 years in the future or something. It might not be immediate, right? So all technology influences like that. So, I mean, getting upset about this sort of a program when you're maybe not upset about something else is sort of like, in my opinion, fallacious. So, yeah, that's kind of how I feel about it, I suppose. So I just feel like on a technical level, there's a lot of um, mystery. There's a lot of logistical mystery for me. Not so much a moral quandary or conundrum necessarily, but I'm not sure. I don't see how using a pest organism to vector a microbe would be better than, say, like having the microbe in a vessel or in a system, in some other sort of system or product, and then using it that way, like we do already with many other products that are biocontrol agents that are meant to inoculate the soil or inoculate the plant or work as an endophyte or an epiphyte or something. And that's all I have to say about that. Yeah, again, this video is going to be online. It will be on my YouTube channel, Zenthanol. If you haven't caught it yet, if you haven't subscribed, I would appreciate if you did. And you have any questions or comments, please send them to me. Send a message to me on Instagram here. Send them in the comments on the YouTube channel, and I'd be happy to discuss them with you. I think this is a really interesting concept, but it's so out there at the moment that it's really hard to comment on. But I will probably be making additional commentary as this program continues. So if you have any information on that, please send it my way. I'd be happy to take a look at that. Thanks.